Welcome everyone today and thank you for joining us for this presentation on information retrieval. The field of IR deals with the process of extracting relevant information from massive datasets in response to a user's query. Think of the times you used to search engines like Google or Bing. The technology that helps you get those results is rooted in IR. Its role in organizing, presenting vast amounts of data in a way that's quick and relevant is essential to today's digital world. Today, we'll dive into how IR has evolved, its core concepts, and why it's so integral to our digital interactions. So, next, we'll talk about the evolution of information retrieval. Let's take a step back and look at the evolution of information retrieval. Originally, information retrieval was very basic, relying on physical card catalogs and libraries. These informations were simple but effective for their time. However, as technology advanced and the internet brought an explosion of information, more sophisticated IR systems were required. This led to the development of search engines capable of processing and indexing vast amounts of digital content. These modern systems have transformed how we access, making it only quicker but more contextually relevant. Core concepts of information retrieval. Understanding the core concepts of IR is vital for grasping how these systems work. So, first, we'll talk about indexing. Just as an index in a book allows you to find a chapter or topic quickly, an IR system's index lets it locate a document efficiently without indexing the system. The would not need to scan every piece of content, which is impractical for large data sets. The next core concept is known as document and queries. Documents can range from web pages and PDFs to tweets and multimedia files. The user's input, known as a query, it is the search phrase or question that they type in. Relevance. This is arguably the heart of IR, determining how closely a document matches the user's query. For example, if someone searches for Python, is it a programming language or the snake they are looking for? Effective IR systems can decipher this context and present relevant results. Next, we will talk about how the search process works. Now, let's break down the search process in IR. Firstly, we'll talk about the user input. The process begins when the user enters a query into the system. Next, the query gets processed. The system then analyzes and interprets the query, breaking it down to understand the user's intent. After that, it starts matching it with the index. The system compares the query against the index of the documents to find matches. The last and final step is retrieval and ranking. The relevant documents are then retrieved and ranked according to their relevance score, which is determined by specific algorithms. The output is a ranked list of documents that the user sees, often prioritized based on how well each document matches the query. This flow ensures a seamless user experience and fast access to information. Next, we'll talk about some common information retrieval models. Information retrieval systems rely on various models to determine relevance and match queries. Firstly, we'll talk about the Boolean model. This is the simplest model using logical operators like and, or not. For example, searching peanut butter and jelly retrieves only documents containing both the terms, while searching peanut butter or jelly retrieves any document containing either or both terms, peanut butter and jelly. Next, we have the vector space model. In this model, the documents and queries are represented as vectors. The similarity between them is measured by the angle or distance between the vectors. The smaller the angle, the smaller the angle, the higher is the relevance. And the third and final model, which we'll be talking about, is the probabilistic model. These models use probability to assess how likely a document is to be relevant to a query. Factors like term frequency and inverse document frequency come into play, helping the system rank results more effectively. Now, we will look at the difference between information retrieval and data retrieval. It is important to distinguish between data retrieval and information retrieval. Data retrieval involves retrieving exact matches from structured data sources such as databases using specific queries like SQL, for instance, retrieving customer details from a database. Information retrieval, on the other hand, deals with unstructured or semi structured data such as text or documents and responds to flexible or natural language queries. As we can see in the table here, data retrieval, the data type is structured, example databases or spreadsheets. In information retrieval, it is unstructured or semi structured, example text or document. The retrieval focus in data retrieval is exact matches, while in information retrieval, it is relevant information based on queries. The query type in data retrieval is specific structured queries, while in information retrieval, it is flexible, often vague or natural language queries. Example of data retrieval is retrieving customer info from a database using SQL queries, while in information retrieval, it is web search engines, academic article search. Primary use of data retrieval is accessing specific data stored in structured format, while in information retrieval, it is searching for relevant content in large text collections. So, as we have seen the table and understood the differences, we can conclude that while data retrieval is used for precise structured data access, information retrieval is about finding relevant content in large and often messy data sets, making it crucial for web search engines and digital libraries. Now, we'll talk about some of the advantages of information retrieval. The benefits of using IR systems are vast. Some of them are fast access to large volumes of information. They can shift through large data sets and retrieve relevant data in seconds. Relevant and ranked results. Results are ranked according to how well they match the query, improving the user's experience. Adaptability across different domains. IR systems aren't limited to one area. They are used in web search, e-commerce, and more. Intelligent query interpretation. While advancements in NLP, IR systems can handle ambiguous or incomplete queries, interpreting user intent more effectively. Continuous learning. AI powered IR systems learn from the user's interaction to refine, personalize search results over time for better personalization and to have a personal impact. Next, we'll look at some challenges in information retrieval. Despite having so many advantages, IR systems face several challenges. Some of them are handling large scale data, managing billions of documents while maintaining speed and relevance is a complex task. Ambiguous queries. Users often provide vague or unclear queries. For instance, searching Apple could either refer to the fruit or the tech company. This causes a huge challenge in information retrieval. And the third and final challenge is ranking efficiency. Achieving a balance between speed and accuracy is challenging. Users expect instant and highly accurate results, which can be difficult to maintain consistently over a long period of time. Finally, we'll talk about the real world applications of information retrieval. IR systems are found in many real world applications beyond search engines. Some of the platforms they are found on are known as are the e-commerce. IR systems power recommendation systems that suggest products based on past user behavior, enhancing the shopping experience. Digital libraries. Researchers use IR to find academic papers, articles, and books efficiently. Social media IR enables users to search for content, hashtags, and trending topics, making social platforms more navigable. These applications illustrate how IR systems shape our interactions across different digital spaces and how useful they are in the real world. Last but not least, we will talk about the future of information retrieval. Looking ahead, the future of information retrieval is heavily influenced by artificial intelligence. Innovations in AI are making IR systems more efficient, context aware, and personalized. Techniques like learning and neural networks enhance how systems understand user intent and content, paving the way for more intuitive conversational search experiences. This evolution means that future IR systems will not only respond with relevant data faster, but will also adapt better to unique user needs and complex queries. Finally, we'd like to thank you for listening to our presentation. And if you have any doubts, please ask them in the comment section or to Supriya ma'am. Like, share, and subscribe.